extra example number 5 from chapter 11, allergies. So we have here one population of U.S. high school students and two categorical variables. One is gender, male or female, and the other is allergies or no allergies is the other categorical. So one population, two categorical. We still use a two-way table. We still compute our chi-square test statistic the exact same way as before. The question we're answering is, do the data provide convincing evidence of an association between gender and having allergies for U.S. high school students? So we're going to do state plan, do conclude. We defined our expected counts as well. So remember, the shortcut for that is row times column divided by table total. So that's the expected count if there is no association between gender and having allergies. So I will make a table of expected counts. If you just do, for example, for female with allergies, if you just do 18 times 23 divided by 40, you would get, so here's just for allergies, our allergies. These are the expected counts for those 4 cells, would come out to be 10.35, 7.65, 12.65, and 9.35. That's what we would expect to get if there is no association between gender and having allergies. So so our state part is for H naught, we would say that there is no association between gender and having allergies. For U.S. high school students who filled out a survey, U.S. high school students. And then our alternative hypothesis is that there is an association. So I'll just write there is, and then repeat everything else. There is an association between gender and having allergies for U.S. high school students. Okay, so state is done, and then our plan is we're going to perform this time, so be sure to name the test that you're using, chi-square test for association. Perform chi-square test for association / independence. Association / independence. If our 3 conditions are met, so 1 is our data is from a random sample. 2 is we would show that our expected counts are all greater than equal to 5. And you actually have to compute them, greater than equal to 5, and you can see in the table that they are all greater than equal to 5. And 3 is we would expect that there are greater than 10 times 40 students, U.S. high school students. So that's our test for independence, is the same as we're used to. And then we're going to compute our chi-squared test statistics. So we do, just like with the M&Ms, chi-squared equals observed, which was 10, minus expected squared over expected. And we're just going to say plus ... And we would do that for each cell. And you would get 0.051 for chi-squared. You have to keep going. Your degrees of freedom are rows -1 times column -1. So that degrees of freedom are 1. So to find your p-value, you would do chi-squared CDF. Chi-squared CDF. You'd give it 0.051 to a large number. Degrees of freedom are 1. And you would get 0.821. So assuming H naught is true, meaning there's no association, there's an 82% chance of getting the results that we did. Okay, so we would conclude that we are not going to reject H naught. There's an 82% chance we would get what H naught says, so we are not going to reject H naught. So because p-value is greater than alpha, our default is 5%, we fail to reject H naught. We do not have convincing evidence there is an association between gender and having allergies. We cannot conclude there is an association between gender and having allergies. Go.